All right, take 73. Problem 5.1, so module 5, problem 1. Okay, so now, Mole Island revisited. We're just going to start kind of in the middle here, and we're just going to do it, okay? We're talking about this chemical reaction right here. We're talking about this thing. And so what I like to do, I like to kind of color code things like this, 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 and that, okay? So we're going to think of things a little bit, and we're going to say, look at the question. How many moles of O2, so that's blue, are needed to roast or make or use, in this case it's use, 10 moles of copper sulfide. So we're going to, okay? So that's what it's asking for. Like all these questions, this is where we start, and this is where we end. All right. So we're going to start, well, let's do something first before we do any of this. And this will apply to all the questions, but we'll do it one question at a time. This particular question, 3 sig figs. So our answer has 3. We're not even going to think about it until we get to the end. It's just we know we have 3 significant digits. You should always do that. All right, getting back to the problem. We have 10. I said 3 sig figs because I'm not going to write that other 0.0. 10 mole of Cu2S. All right. And the whole point of a balanced chemical equation is to get these coefficients and for this one ratio that we're about to write. Okay. For every 2 moles of Cu2S, there are 3 moles of O2. Okay. So that ends up being 15 moles of O2. 3 sig figs, so we should have 15.0 moles of O2. All right, that is the answer for that problem. All right, it asks for moles of O2. Again, we're on the island. The whole point of the island is for this ratio right here. That's it. So that's A. All right. All right, moving right along. So our next problem is how many grams of SO2 are formed when roasting, when burning, I guess. 10 moles of Cu2S, okay? So for this one, we're going to start with this. We're going to end with this, okay? Again, looking at this, same kind of problem, 3 sig figs, okay, 10.0. So that's 3 significant digits. So again, just knowing that at the end, we have 3 sig figs. So we are going to, this is B, this is B. We're going to start again with 10 moles of Cu2S. We're going to use our mole island. We're going to use our equation. We're going to go from Cu2S to SO2. So for every 2 moles of Cu2S, okay, the 2's right here. So for every 2 moles of that, we have 2 moles of SO2. So that means we have 10 moles of SO2. All right. And now we're just going to use, we're going to grams. So now we're going to get off the island and get on a boat. Okay, we're going to get on our molecular weight boat. So for 10 moles of SO2, for every 1 mole of SO2, there are 64.06 grams of SO2. So we end up with 640.6 grams of SO2. Again, 3 sig figs, 641 by Kaylin grams of SO2. 3 sig figs. All right, so that's that part of the problem. Last part of the problem. How many kilograms of O2, so again, that's where we end, are required to form Although it's not forming. Oh, oddly enough, prior to, sorry, that word just threw me off. I've never read this that closely. How many kilograms of O2 are required to, it should be react with, 2.68 kilograms of Cu2S, okay? So once again, this is where we're going to start. We're off the island because we're in grams, and we're in kilograms actually. And so we have to go from 2.68 kilograms of Cu2S. Our molecular weight is always in grams per mole, so we have to first get 1 kilogram of Cu2S. Remember, it's 1 times 10 to the third grams. Remember which one's smaller, and then it's one step away. Remember our metric system. Okay. And then for Cu2S, oh wait, let me stop there. I'm sorry. I want to equals 2680 grams of Cu2S. Now we have 2680 grams of Cu2S. Times 159.16 grams of Cu2S, and 1 mole of Cu2S equals 16.84 moles of Cu2S. Now it's just like any of these problems that we did up here. Oops. It's exactly like this one, okay? But instead of 10, now we have 16.84. So we do it the exact same way, okay? We're even going to the same thing. We're going to O2, all right? So 16.84 moles of Cu2S. And then just looking at our ratio, we have 2 Cu2S's, 3 O2s. So 2 moles Cu2S, 3 moles O2, equals 25.3 moles of O2. And then we're trying to take that to kilograms. So 25.3 moles of O2, 1 mole of O2, there's 32 grams of O2, equals 808 grams of O2. And now 808 grams of O2 times 1,000 grams of O2, 1 kilogram of O2 equals 0.808 kilograms of O2. That's where we are. That's what it is. Okay, so that's our answer to that one. Hope that helped.